Welcome to our webinar today on chemical compatibility in BlazeMaster CPVC. We're going to teach you everything that you need to know about chemical compatibility with Lubrizol CPVC products. With me today, my name is Lainey Leota, and I'm the Global Segment Manager for our Fire Protection segment here at Lubrizol. And I'll give Michelle Knight and Emily Nime a few minutes to introduce themselves as well.
Hi, I'm Michelle Knight. I've been in the CPVC R&D department here for 36 years, recently promoted to technical fellow in the corporation, and I have specialized in materials testing, chemical compatibility, and failure analysis.
My name's Emily Nime, and I've been at Lubrizol for a little bit over a year. I have about 6 years of materials testing and chemical resistance experience.
Awesome. And then we have my colleague Dominic Coletti here answering the chat. Dominic, do you want to introduce yourself as well?
Yes, my name is Dominic Coletti. I am the Fire Protection Market Specialist at Lubrizol, and I will be taking some questions in the chat. However, we're going to have hopefully an extensive question and answer session at the end.
Awesome. Thank you, guys. And to Dominic's point, we do have an hour scheduled for presentation and then 30 minutes scheduled for Q&A. Usually we do about 15 minutes of Q&A, but because we always get so many questions on compatibility, I figured it'd be good to sort of extend that out. So you're welcome to type the questions in the chat or in the Q&A section, but we'll likely get to them at the very end. And if we don't have time to get to them, then we'll respond to you either in the chat or just follow up with you afterwards. For those of you who are here for NICET credits, there will be a QR code and a link shared in the chat at the end of the session that you just fill out your information, answer a couple questions, and then you will receive a certificate by the end of the year. We have been having issues with our certification or our certificate generation program. And we still unfortunately have not gotten it to work. It's a Microsoft thing. So in the event that we aren't able to send out certificates, what we did for our last webinar is we sent out an email that was basically the same thing as a certificate, and you should save that email as a PDF and make that your certificate. Hopefully that won't be an issue, but just wanted to give you a heads up. So again, any questions you have, please put them in the chat, and we look forward to getting them to answer them live in person at the end. But for now, we will go ahead and get started. All right, so this isn't your typical compatibility webinar. We're going to get into the science of it, but then what's very important too is that we get into the practicality of dealing with CPVC on a job site and setting up contractors and setting up contractors for success. So there's just to kind of pique your interest here, I put 3 things that are commonly misunderstood or common myths that we're going to bust, and then hopefully you'll learn a lot more as we move through here. But we're going to teach you that correctly installed FPUF can be used with BlazeMaster CPVC. It is in fact not incompatible. Also, giant myth is that UV light exposure causes BlazeMaster to go bad, but that's not true either. It just changes the color, and Michelle and Emily will teach you more about that. Giant myth is that we profit from our system compatible program, from having people send in their product to be tested as compatible with BlazeMaster, and that is not true either. So those are just 3 tidbits of information that hopefully pique your interest of the type of stuff you're going to learn, including how we're going to set you guys up for success on a job site. But first, a little bit about Lubrizol. We're Lubrizol Advanced Materials. We have a CPVC business within that, and antifreeze business within Lubrizol. Lubrizol is a Berkshire Hathaway company. We're a specialty chemical company. And our product lines are BlazeMaster CPVC and FreezeMaster Antifreeze, which are used for fire sprinkler systems, and then FlowGuard Gold, which is used in residential plumbing systems, and Corzan, which is commercial plumbing and industrial systems. So all of what we're going to talk about today applies not only to BlazeMaster, but to all of our CPVC products. So if you have any questions about our other products, feel free to give us an email and shoot us an email, and we'll get back to you if you're interested in learning more about those. But today, due to this being a fire protection webinar, we'll just focus on the BlazeMaster component. So Lubrizol manufactures the powder and the pellets that go into the pipe and fittings. We do not actually manufacture the finished goods. We are the science behind the finished good product, and we partner with world-class manufacturers to manufacture BlazeMaster pipe and fittings. And our two partners for North America that serve the world are IPEX and Viking. Most of you are probably familiar with Johnson Controls or Tyco. They used to manufacture our product and sold off their CPVC business to IPEX. Fortunately, IPEX was already a customer of ours, both on the BlazeMaster side and on the Corzan side. So we already have a really good working relationship with them. And about, I think it went into effect a year and a half ago, maybe a little less. And that was sort of a seamless transition from our standpoint and working with them. And they make just as good of a quality of product as JCI did. And then we've been partnered with Viking for a while too. And then George Fisher, they make pipe only for aspirating smoke detection systems, or ASD systems, or what are commonly called BESDA systems. So when you're dealing with these three, you are dealing with BlazeMaster product. And so now I'm going to turn it over to Michelle and then Emily to understand so that you guys can understand the science. And then I will come back on a little bit later and talk about how it applies to the job site. So Michelle, I will turn it over to you.
All right. Thanks, Lainey. So the first thing I want to talk about is just a little terminology and what does it mean to be compatible versus incompatible. A lot of people have the wrong perception of compatibility and incompatibility. They kind of think of them as polar opposites. You're either compatible or incompatible, much like you're either alive or dead. There's nothing in between. And that's not the case. The reality is more like a temperature scale. Chemicals vary in the amount of effect that they have. And because they vary in the amount of effect that they have, some chemicals have a very strong effect on the CPVC and cause a lot of weakening. Other chemicals have lesser or a very weak effect on the CPVC and don't cause too much detriment to it. So other factors generally contribute to the failures, and most commonly that would be the stress in the piping system. So when we're talking about compatible or incompatible, we're not talking about a yes or no, black or white kind of question. It's more like how hot is too hot on the temperature scale. So just to cover compatibility on another angle is not many materials are impervious to everything around them. Down there at the bottom, that's a picture of a little diamond sitting on a gold nugget. Those two materials are pretty impervious to things, diamond and golds. But if you need something that's completely impervious, you're going to pay a diamond or gold kind of price. So metals have their own set of things that they are incompatible with or sensitive to, and these include some pretty darn common chemicals: oxygen, salt, water, the quality of the water, its pH, its sulfur content, its other type of content in the water may affect it. Microbes living in the water or on the pipe wall can affect it. They will secrete acids as part of their metabolic process, and the acids will dissolve or corrode the pipe. Galvanic action, everybody's familiar with that. When you connect two dissimilar metals, you can have actual current that will corrode the piping system. And stray electric current, for instance, if someone grounds the electrical system to the piping system, that can cause corrosion of the piping system as well. So that's a summary of what metals might be sensitive to. It's not the same with plastics. Some plastics are sensitive to oxygen, salt, water quality, and UV exposure, but typically it's more organic chemicals that can be found in a variety of different kinds of products that you might come across on the construction site. CPVC is not sensitive to oxygen, not sensitive to salt, water quality, acids that might be secreted by microbes. It's got excellent resistance to all those kinds of things. But there are some chemicals that you'll find in certain certain construction products that might affect the plastic. So what is CPVC? A little more background information here. CPVC stands for chlorinated polyvinyl chloride. So PVC, polyvinyl chloride, everybody is familiar with that. It's used in 1,000,001 applications, both in the construction industry and other industries. There's vinyl siding, vinyl flooring, vinyl wall covering, all of that. Whenever you hear vinyl, that's all PVC. CPVC is chlorinated polyvinyl chloride. So we start with PVC and we add additional chlorine to it. PVC is already 57% by weight chlorine. We increase that with UV and using UV and heat to catalyze the reaction. We add more chlorine to it, and that gives it higher temperature resistance, better flame and smoke resistance. So it makes it more suitable for hot water plumbing pipe and also fire sprinkler piping. You can't use ordinary PVC for fire sprinkler piping. You need CPVC because it's more fire resistant due to the extra chlorine. And I just want to point out here, again, we're making CPVC using pretty high intensity UV light, and we're not degrading it during that process. So a little bit of UV from the sun is certainly not going to hurt the CPVC molecule. So once we've made the CPVC itself, it's compounded. We add additional ingredients into it. There's typically 10 to 15% of other types of ingredients. Obviously, there's a pigment to make it orange. We add some heat stabilizer, impact modifiers, and a variety of other ingredients to give it the final properties we need to make good pipe and fittings out of it. And we sell it, as you see, in those little piles of powder and pellets over there in the picture on the right-hand side. That's what leaves our plant is rail cars full of powder and pellets that go to the customers Lainey mentioned, Viking and Ipex and George Fisher, and they are the ones that make the pipe and fittings finished goods out of it. So this blob that you see in front of you is kind of a schematic of a CPVC molecule. A plastic material is, as you probably heard in some science class somewhere, it's a long chain molecule, and it's actually the little gray blobs in the middle that are the chain in this case. The big red blobs are the chlorine that we put on the backbone of the molecule. And that chlorine, I like to call this kind of a little armadillo of a molecule. The chlorine is a big, huge atom that really protects the backbone, actually physically protects the backbone from chemicals that might degrade or break down that plastic chain. So, you know, they're so huge, they're literally like armor plating on the molecule. So this gives it excellent resistance to free radicals created by UV light. Chlorine, it does not matter what the chlorine content of the water is, or if you need to shock chlorinate your system to, you know, kill microbes in it or something, you can't put enough chlorine in a fire sprinkler system to harm it. In fact, it's used in very high chlorine applications in the chlorine production industry in our Corzan products. And it's frequently installed outdoors, particularly, again, plumbing and Corzan are installed outdoors. And they're not being degraded by the UV light there. The BlazeMaster product has very, very similar UV resistance. And again, it's used in industrial applications for handling some really, really corrosive things like battery acid, caustic soda, high strength hydrogen peroxide, things that will really oxidize and degrade other kinds of materials are pretty harmless to CPVC. So I've mentioned it already, but BlazeMaster is not incompatible with UV light. It does not affect the long-term pressure bearing capability. It does not decrease the service life of the CPVC. It may discolor it a little. The orange pigment doesn't hold up as well as the CPVC does. And it may age a little and become hard to cut. But if you can, and we do recommend if it's been laying around in the sun, you use a gentler method of cutting than a ratchet cutter. You might want to use a fine-toothed saw or a wheel cutter. But if you can cut it without cracking it and get it installed, it's not going to affect its long-term pressure-bearing capability at all. Or if it needs to be installed exposed somewhere where it's getting a little bit of light through a skylight or a window or something like that, that's not going to affect it at all either. So getting on to the subject of compatibility, CPVC, there are three types of plastics, and CPVC falls into the first group, which is called amorphous plastics. Its strength depends entirely on chain entanglement. Other types of plastics like polyethylene or polypropylene are semi-crystalline. They're held together by those crystallites. They're very weak in between the crystals, which are those areas of parallel lines that you see in the image there. Those hold the plastic together. In between them, it's fairly weak and permeable. And then other types of plastic like fiberglass are literally held together by chemical bonds. The molecules are all tied together. And this makes a difference in chemical resistance when the molecules are tied together or crystallized. Chemicals have somewhat less of an effect on them, so those types of plastics are a little bit less susceptible to environmental stress cracking than amorphous plastics like CPVC. With CPVC, it's kind of a benefit that chemicals have an effect on it. It gives you the ability to do solvent cementing. You're probably aware you can't solvent cement polyethylene, polypropylene, fiberglass. Because chemicals can affect CPVC, we can solvent cement it, which makes for a nice, easy installation process. But it does mean that other types of chemicals as well can have an effect on the plastic. So I like to use this analogy when I talk about the factors that affect environmental stress cracking failure, because everybody in this industry is super familiar with the fire triangle. You know that you need three different elements to initiate a fire and to keep it going. You need fuel, you need air, you need heat. It's also very similar with the performance of plastics. It's not just the fact that the chemical is present that is going to cause the plastic to crack. In a lot of cases, these types of chemicals can be applied to CPVC and they'll last for years and years and years because you don't have the other contributing factors at a sufficient enough quantity. So typically you need some participation from mechanical stress on the system, and we'll talk a little bit about where mechanical stresses can come from in a sprinkler system. And then, of course, the properties of the material and the part are always going to play a role. So we'll start with material and part properties. As I said, that's a CPVC molecule. That's not something that's going to change. We're using basically the same molecular structure we've been using for the last 40 years. The compound also, because it's UL listed, does not change very much at all. It's very hard to change a UL listed product. That's what you see on the right there. When it's processed into pipe and fittings, this is where it's really, really important to go with a high quality, well-known producer because we're relying on molecular entanglement, that picture on the bottom left there. Molecular entanglement is achieved by the manufacturers of the part. They've got to break down those powder and pellets and get all the molecules tangled up really well in order to get the final strength of the CPVC where it needs to be. So it's very important to work with high quality manufacturers with a good reputation. So mechanical stresses, of course, the pressure inside the pipe is always a mechanical stress, of course. The pipe's got to hold pressure inside of it. There's also normal installational stresses. It's got to support its own weight and the weight of the water in between the hangers and so forth. You may or may not have thought about this, but I think you're all aware there's a tapered socket in the fittings, and the bottom of the socket is slightly smaller than the size of the pipe. That makes for a super tight joint. In fact, the joint is the strongest part of the system when it's properly made, but it does put some stress on that fitting socket when you run the pipe home into the bottom of the socket. So there's some stress there. Those are all normal kinds of stresses. But then, of course, we're all familiar with pictures like you see in the top right there, where other trades come in and do things. They may try to shift the pipe out of the way. They may rest cables and conduits and all sorts of things on top of the pipe, or press up against the pipe with beams and other types of support structures. So stresses can also come from those kinds of areas as well. So now I'm going to hand it off to my colleague Emily Nime, and she's going to talk to you about the different types of chemicals that can affect the plastic and where you can find those chemicals in construction products.
Great, thank you so much, Michelle. So these chemicals are going to generally fall into three main categories. Plasticizers, which are essentially added to rubbery material to make it flexible. And we're going to dive deeper into this on the upcoming slide. Natural and synthetic lubricating oils. This essentially includes oils and fats from vegetable or animal sources, as well as synthetic lubricants. I did want to make a note, though, that petroleum-based oils have a minor effect on CPVC, whereas these natural and synthetic oils tend to be a lot more aggressive. And surfactants also are found in detergents and soaps. In terms of severity, when looking at all these chemicals, plasticizers are definitely going to be the most severe, whereas surfactants are going to be less severe to the CPVC, but they're still going to cause issues over time. So like I mentioned before, plasticizers are used to make hard things soft, and you're going to find them in a lot of different places on the job site. So a common source of plasticizers include wire and cable, like for communication cables. They typically have that like soft and tacky feel. And that soft and tacky feel essentially is a sign that wiring typically has plasticizers. But again, all wire and cable is not created equal. So Romex wiring, which is a wiring that carries electricity from light fixtures and outlets, is typically compatible because it typically is nylon or polyolefin jacketed, and those types of wires have that rigid and slick feel to them. Another source of plasticizers is tube insulation. So if the tube insulation feels like squishy or soft, it's probably not compatible with CPVC. But if your insulation feels more rigid and slick, like a pool noodle, you should be fine. Again, do the field check. So like if it's soft and flexible, it probably has a plasticizer and it's incompatible. If it's rigid and slick, you should be safe. You're also going to find plasticizers in materials like caulks and fire stops. Later in the session, Lainey's going to talk more about our system compatible program, and the program will give you a list of fire stops that are safe to use with CPVC, and I definitely recommend that you stick to that list or reach out to us before you use something off the shelf. We're always more than happy to help. And I did want to make note that if you're looking for general sealing, like filling a gap in a wall, something that's silicone based should be fine. But of course, if you have any questions, please reach out to us, and we're more than happy to help. Electrical tape also is another source of plasticizers. It doesn't pass the field test. It's stretchy, it's flexible. So any tape that feels like electrical tape or electrical tape is incompatible. But all other tapes are fine, like duct tape, masking tape, scotch tape, paper tape, all fine with CPVC. Another source of plasticizers could also be weld penetrance, and this is more relevant for hybrid systems. So if you're testing steel pipe welds in a hybrid system, the plasticizers could wash down the CPVC system and cause cracking. So it's just best to try your best to keep those penetrants out. Fragrances are also incompatible with CPVC, and we see this when people do air pressure tests and they'll put something like a essential oil to detect the air leaks. It's definitely not a great idea. It will crack your CPVC. And just to test, like if a rubber material is safe, just ensure it doesn't have phthalates, adipates, trimelatates, or dibenzoates. And of course, if you're not sure, consult the system compatible list or reach out to us. We're always happy to help.
Emily, one thing I want to mention here is we frequently run into contractors that use peppermint oil to detect leaks. That is certainly not something that we recommend using, or anything that smells, cologne, things like that. No fragrance.
Yes.
Fragrances.
No fragrances, please. Another source of environmental stress cracking agents are natural and synthetic lubricants, like I had mentioned before. And a good source of natural lubricants is kitchen grease. When you're cooking in your kitchen, the grease just simply gets everywhere. So if you do have unexposed or exposed CPVC, the grease can settle on it and cause cracking. If your system does need to be exposed, you can paint your pipe as a barrier if your jurisdiction allows, and or you could apply a compatible insulation to it. If you're using cutting fluids, we recommend anything that's petroleum based, because anything that's marketed as like a green or plant-based cutting fluid typically will have a vegetable oil base, and that is incompatible with CPVC. And thread sealants also can have some incompatible oils in them, like linseed oil or castor oil. So we, of course, recommend you consult the system compatible program. We do have a lot of listed thread sealants that are compatible, or feel free to reach out to us. Again, we're always more than happy to help. And the last chemical that we'll be really talking about in depth is surfactants, which I had mentioned before are synthetic detergents. And you can find surfactants in some leak detectors, like the soap blowing leak detectors. Again, if you're looking for a leak detector that's compatible, please check out our system compatible program. We have a few listed. Surfactants are also found in different cleaning products and disinfectants and mildew treatments, and of course, compatible versions can be found on our program. And again, some typically incompatible surfactants include dishwashing detergents with synthetic detergents, termiticides, insecticides, fungicides. Those sorts of products have solvents and have surfactants to help disperse the product for application. And of course, a strong emphasis on fragrances. They are environmental stress cracking agents. Please do not put them in your system. So another hot compatibility discussion in the industry is spray polyurethane foam. Is it compatible with CPVC? So like most of us do know, Polyurethane foam is a two-part product when it's applied. There's a part A and a part B, but CPVC is not compatible with either part A or B. But when they react, it foams up and its final product is compatible with CPVC. And to understand that, we need to look at the science behind it. So when the monomers lock together, they form a hard plastic, and all those additives that are incompatible with CPVC get trapped inside the foam bubbles, making it difficult to penetrate the CPVC surface. So essentially, the structure of the foam locks those additives, making it not harmful to CPVC. And the key to this proper foam is proper application. So the application should be even, not too thick. Make sure it's uniformly coated, covering everything completely, like the image on the left-hand side. If the foam doesn't foam up like we see in the picture, or is partially put on, this will leave the additives on the surface of the CPVC, and this will cause cracking and failure. And just as a side note too, when you're applying polyurethane foam, it can get up to 300 degrees or more in the foam. So just put it in on thin layers so the heat can dissipate, and put expansion loops if you need to. And now a common question we also get asked about is CPVC compatible with paint? And yes, it is. So we recommend any water-based paint or acrylic paint, but most other paints are fine, like spray paint, oil-based, just latex. Just apply a thin coat to it, avoid puddling around the joints, but there is an exception to this. The only paint that is not really compatible with CPVC is two-part epoxy, because just like polyurethane foam, CPVC is not compatible with part A or B of the epoxy on its own. So if you have to use it, just keep the coat thin and make sure there's no excess. But at that point, it's honestly easier to stick to a one-part paint. And of course, before you start painting your pipes, just confirm with your jurisdiction that it's okay to do so, before you cover any marking or print lines. And of course, if you need a letter, please contact us and we'd be more than happy to provide you with one. So I kind of wanted to end this part of the presentation talking about things you don't need to worry about, because I did give you plenty of things to worry about. So paint, like we discussed, is compatible with CPVC. Most other forms of insulation like fiberglass or blown-in cellulose is compatible with CPVC. Most tapes, besides electrical tape, is compatible with CPVC. If you need to mark up your pipes, Sharpie is not a problem. Drywall, mud, and spackling is compatible with CPVC. The Mylar ducting insulation, like you can see on the top right-hand side, is compatible with CPVC. And the spray-on fireproofing for steel, if some gets sprayed on the exterior of CPVC, that should be fine as well. So of course, if you have any concerns or questions, please reach out to us, and I'm going to hand it over to Lainey to tell us more about the System Compatible program.
Sure. So thank you, Emily, and thank you, Michelle. Great job. And there's a ton of questions in the chat that I'm looking forward to getting to. But before we get there, I want to talk a little bit about our FBC System Compatible program. So FBC is our motto is that it takes the guesswork out of chemical compatibility. And I wanted to show you some of the tools that we have that should be used more, I think, and are kind of self-service, so they don't have to wait for us to come back with an answer. What is the FBC System Compatible program? Lubrizol invented CPVC, or Lubrizol company invented CPVC, and we also invented compatibility to go, or we didn't invent compatibility, but we invented a compatibility program to go along with it. So what does FBC stand for? I think that's important to recognize. Is as we went over before, there's 3 CPVC brands that Lubrizol has: FlowGuard, BlazeMaster, and Corzan. So that's FBC. That's what that stands for. We're the oldest and most comprehensive program in the industry. We have far many more products on our list than competitors. And we developed the protocols and the testing protocols for assessing chemical compatibility, but we actually contract with a third-party testing resource that does the testing themselves on an annual basis to determine the compatibility of the product. I want to be clear that our program applies only to our brands of CPVC. So in this case, we only assess compatibility with BlazeMaster, not competitive materials. So if you're dealing with a non-BlazeMaster brand, you need to go to the manufacturer of the other brand to assess compatibility, because while we typically agree on things, there have been a few instances where we've had something on our list that we find that it's incompatible, and then the other had it as compatible. And you want to make sure you're paying attention to what the manufacturer of the product says. Typically we're right, or actually we're always right, but again, just know that we can only speak for our own product. And in a few slides, I'm going to go over some of the tools that we have available to you guys to help disseminate this information a bit more. So the first thing I wanted to talk about is our compatible product finder tool. And that's a list, a list of products on the compatibility program. We also have on that same tool a list of products that are known to not be compatible with BlazeMaster. And then what I find as the most useful tool on there is the other chemical compatibility topics section, where we have guidance about all construction type materials. And I have other slides on here to show you how to do this in slide form, but I was thinking I might as well just show you our website and teach you how to navigate it yourself. I guess Emily or Michelle, can you confirm that you can see my screen and I'm not still showing the slideshow?
Yes, I can see.
Yes.
Okay. So if you could, FBC, system compatible, or FBC might be difficult to remember since you're not familiar with all 3 brands. But if you go to blazemaster.com, this is our homepage. And if you go to compatibility here and go to find FB system compatible products, it will take you to our system compatible program, or FBC systemcompatible.com. So there's 3 steps that we encourage you to take when you are determining whether or not something is compatible. There's other educational type resources on here, white papers, videos, things like that. But for now, we'll just talk about, let's determine whether or not a particular fire caulking is compatible. So we're looking for find FBC system compatible product. And I clicked on that number 1 here, and it took us down here. You can select the category you're looking for, whether it's fire stop sealant, freeze protection, antifreeze, spread sealant, things like that. So since we're looking for let's just do freeze protection since it's right here. You can select freeze protection. And then here is a list of all of the products that we know to be compatible with BlazeMaster CPVC because they have submitted for testing. Let's say that there's an antifreeze on here, or an antifreeze that we're wondering about its compatibility is not on this list. The next step is to go to review incompatible products. So you go up here, and we have a list of things that we have found to be incompatible either through our own testing, or it's been sent into us from the field and we've identified it as incompatible and having caused a failure, or we've assessed the material data sheet and it has incompatible ingredients. So again, we're looking for an antifreeze. We go here and, well, I guess we don't have an incompatible antifreeze on here, so I guess that wasn't a good idea. But if we go to spread sealant, here's spread sealants that we have found to be incompatible with CPVC and BlazeMaster specifically. If you still don't find what you're looking for on there, this is the section that I find most helpful. And that's the third section, review other chemical compatibility topics. This is where we have a list of, I can't remember, I think it's 22 or something like that, different categories where when any time that you email us and say, hey, is this compatible, is this product compatible with BlazeMaster, we will basically send you exactly what's already on this page. It explains everything, explains the types of things that you should look for or not look for, or in some cases, like paint, for example, there really isn't, like Emily explained, there's not an incompatible paint unless it's a two-part epoxy paint. And we give you information around that. We had, a lot of questions about wiring and cable. We put it simply here that, nylon and polyolefin jacketing and on many types of electric carrying wire is compatible, right? So there's a lot of information on here where this is our website. You don't necessarily need a letter or anything that says that you can just show, the AHJ or the GC exactly what we have on here, and it should be okay. Obviously, like Emily said, please reach out to us at blazemaster@lubrizol.com if you need more support. But most things that you're going to ask are going to be answered on this website that you can easily get to. And a lot more questions in the chat regarding some of this stuff. So we'll get back to it, but I just wanted to sort of demonstrate that that is how you can find your own information. And then also we have an app called the FBC app, and it's available both on iPhones and Droids. And it's basically just that website in app form. And we'll skip through these since they already did it. One thing we have, so in that first step, where I put that, in that first step when we were looking for FBC system compatible products, those products on that list mean the following 8 steps here, is that the manufacturer of those products, of that antifreeze or of that thread sealant, etc., voluntarily sends their product once a year for testing to a third-party lab. They also, when they become part of our program, agree to not change the composition or the material makeup of that product without notifying us. And our third-party lab conducts audits on them to make sure that they're not changing anything. And then annually they do it over and over again. So sometimes we do have manufacturers come off of or products come off of our program, and they're no longer on our compatible list, but that does not mean that they are incompatible. Typically, it just means that they chose not to submit their product for testing again, not because they changed the formulation or anything like that. It was just because they, maybe they don't see the value in doing it again or something like that. If that were to happen, we would definitely, if a product on our compatible list suddenly became incompatible, we would absolutely make sure everyone knows. But to date, that has not happened and likely won't happen. But that FBC logo that you see here on the right-hand side of the screen is all the products on our list have that FBC mark on them. That should give you the confidence to say, if there is absolutely no question about its chemical compatibility because it is part of our program. So there are, as I just showed you, there are several products, if not hundreds of products on our program. And so really encourage your GC to put that in some of the specifications, or, you should put it in your own specifications if you're a contractor engineer. The FBC approved product should be used. One of the questions we get a lot is we do have several categories of products on our list, but why aren't there any paint or wire and cable or general purpose caulking? And that is because those categories specifically are so broad that there is no way that we would be able to test any or all of them, right? There's so many different manufacturers and brands and lines within those brands and things like that. So that's why we have that other chemical compatibility topic page to help with some more generic or general products like that. So some best practices when it comes to the field is what we just went over. Look for the FBC on the labeling or the packaging. And if there's that FBC mark, you're okay. If it's not there, then you can go to our website, go to the app, and follow those 3 steps to verify the compatibility. If not, if you still have questions, you can reach out to us at blazemaster@lubrizol.com, but make sure you're including the SDF or the material data sheet of the product. I will say that a lot of times there's proprietary ingredients in the product that you're asking us about, so we're not able to confidently look at it and see all of the ingredients. So sometimes we might not be able to give you a straightforward answer because not all of the things that we need to know are listed on the sheet, but we will certainly try our best. So when it comes to the actual job site, I mentioned a few of them already, but we very highly recommend including language about compatibility in the specification. That's a CYA, so to speak. Super important that you're educating the general contractor because a lot of the issues that we see are not caused by the fire protection professionals, right? They're caused by other trades. And so it's super important that other trades are informed. And we have a few tools to do that, which I'll go into, but one of the ways, and it's also a CYA, to be honest, is printing out the chemical compatibility job site warning and posting it in public areas across the job site so that other trades are aware that, you know, there are some things that should not come in contact with the fire sprinkler system. I think making sure that the building owner is aware, or at least that the GC is educating the building owner, is super important as well, because again, not everything happens upon installation, or chemicals or incompatible materials aren't always introduced on the job site. Sometimes it can be years down the road when a mold remediation company comes in, or you know, there's other trades that are, you know, servicing the HVAC or whatever, that's when incompatible materials are introduced. So it's always good to make sure that the building manager, the property manager, is aware of how to care for a fire sprinkler, CPVC fire sprinkler system, and that any work they have done or any renovations, things like that, that those trades are aware as well. Also, you know, you can isolate or protect the pipe from potentially incompatible products by putting, you know, some coverings over them. We can get into that as well in the Q&A section. And then there's some free resources that are available from ourselves, from Viking, and from IPEX. I'm sorry, this says JCI, not IPEX. That we'll go over. Here is an example of some job site notices. This is what we recommend posting in public areas around a job site. Again, I'm not naive enough to think that this will solve all problems by any means, but again, it is a CYA and just a way to get information out there. Another thing that both our customers have is turnover letters. This is meant for the building owner, and it's also a great tool for the CPVC. I'm sorry, for the GC. And this just goes into how to care for your CPVC fire sprinkler system, things to watch out for, basically everything that Emily and Michelle just went over. These can be found on IPEX's website as well as Viking's website. If you go to blazemaster.com, all the resources are there as well, and you can download them and print them yourself. And so now we are finally at the Q&A portion of our program. And I think I'll just start with some of the questions that we have in the chat. And in about 15 minutes or so, I will put the NICET credits up here for you guys to take that while we continue. But I'll ask Emily and Michelle to come back on, and I'll start with, do we know if wire for fire alarm systems typically have a plasticizer?
Well, I don't know about that specific wire in particular, but usually you can find the jacketing material on the wire specification cut sheet, the cell sheet, something like that. If it says it's a PVC jacketed wire, that's something to be concerned about. If it lists any other kind of material other than PVC or vinyl, if it lists something like nylon, polyolefin, polyethylene, polypropylene, that would be fine.
Awesome. I think that covers a lot of the questions around wiring and cable here. Someone PM'd me earlier asking about insulation over piping system, over duct and plumbing type systems. What about insulation?
Like tubing insulation? I'm not sure I understand the
So
question.
compatibility with CPVC and the insulation over duct and plumbing. So I guess let's ask both, just regular insulation and then tubing insulation.
Yeah, so Emily gave a lot of good examples of those, like the metallized insulation over some ducting systems is fine. Batt insulation is fine. Most types of insulation are going to be fine, except for that particular type of tubing insulation that feels soft and squishy as opposed to crisp like a pool noodle. And of course, SPUF is a special case.
Right. Yeah, I think a good rule of thumb is that if it's squishy, don't don't put it in contact with CPVC.
Speaking of tubing insulation, I saw another question in the chat about can you use that as a barrier? And the answer is kind of yes and no. It'd be a great barrier for something like cable because it's not going to move around a lot. But in some cases, I have seen some cases where it actually acts as a trap for mold chemicals, for instance, where it's got a split in it so you can put it over the pipe and the chemicals will get inside the insulation and be trapped in there. So depends on how you want to use it. In some cases, it would be a good barrier. In other cases, you want to be more careful that it's not actually going to be a trap.
It's a good question in here about does processing and does the manufacturing process affect compatibility?
Well, it affects the material properties. And so if there's a defect, that's going to affect not only the performance of the part, but it can also affect the chemical compatibility. A defect is obviously a not good part, a not good area in a part. And so not only is the strength affected in a defect area, it's also going to affect chemical compatibility. And again, quality is always important. A poor quality part is not as resistant as a high quality part, which is why the partners that we choose to work with for our BlazeMaster products are high quality, well known, good manufacturers.
One question we get a lot is how long does something take to fail? And I know that's a very difficult question. Once an incompatible material is introduced, how long does it take to show up?
Yeah, again, that's a dependent question. It after it's introduced, certain types of things like mold inhibiting chemicals, mold sprays, if it's incompatible, sprayed around the building, you'll typically see it within a couple of years. Other things like incompatible wire and cable or fire stopping caulk, the chemical has to take some time to migrate out of that rubbery material and into the CPVC. And in some cases, it can take 5 or 10 years for that to happen.
Yeah. And I just want to echo, it doesn't matter what type of, everything acts a little bit differently because of that fire, or not the fire triangle, because of the triangle that, the failure triangle that was shown at the beginning. It's not a black and white answer that if one chemical is introduced, you'll see a failure within 4 or 5 weeks or 4 or 5 years. There's so many outside factors that we cannot confidently give timeframes for things like that.
Correct.
Another question we commonly get is what happens if an incompatible chemical is introduced to the inside of a system? What do we recommend happens then?
That's a tough question. There aren't a lot of good ways to get it out of all the nooks and crannies in a fire sprinkler system because there's so many dead end drops and things. If you want to try to wash it out, we recommend a very mild detergent like a solution of trisodium phosphate. But we can't guarantee that that's going to work because there's so many dead ends and nooks and crannies. There's no good way to wash the inside of a piping system.
Yep. Let's see.
I saw somebody ask about zip ties. Zip ties are fine, but again, you want to be sure the cable you're zip tying to it is fine. Um, Zip ties are typically made out of nylon or polypropylene. Those are perfectly compatible. But they were specifically asking about zip tying cables to the pipe, so be sure the cable is compatible.
What about asphalt shingles, tar paper, or asphaltic liquid tar?
I would not recommend you like seal around the pipe with liquid asphalt. But if it's just going to be pressing up against like shingles or something like that, that would be okay. But I wouldn't put like hot tar on the pipe on purpose.
What about in hybrid systems where you switch over to steel pipe? If caustic or biological growth occurs in the steel pipe, can it spread and degrade the CPVC it's connected to?
CPVC is perfectly impervious to microbiological growth. I mean, you don't want it in the system. It'll make the fluid smell nasty, but it doesn't affect the CPVC. The acids that the little bacteria give off as part of their basically eating and pooping. They give off acids. They poop acid. Um, it doesn't affect the CPVC.
Awesome. A few questions about what FBC stands for again. That's FlowGuard, BlazeMaster, Corzan, our three CPVC products. About solvent cement. Can you talk about the effect of, first of all, how solvent cement works, I think is where to start, and then how it can affect something from affect or not affect the pipe from a compatibility standpoint.
Okay, well, if you've ever made a solvent cement joint in your life, and I hope you have, if you're on this call, you will know that the cement is made to soften the surface of the pipe and to soften the surface of the fitting, so that when you push that joint together, the cement's not what's holding it together. You're actually pushing those softened molecules of the pipe into the softened molecules of the fitting and welding it. It is a chemical weld, not an adhesive joint. So that's a great thing as far as joint strength, but you just want to soften the surface. You don't want to soften the whole wall of the pipe or the whole wall of the fitting, because then it will be soft, and soft is not good for a piping system. It needs to hold pressure. So you want to use the right amount. You want to use, enough to soften the surface, but not enough to soak in and make the whole wall soft. So you don't, especially on the inside of the pipe, you don't want to get an excess, because there's no real good way for those solvents to evaporate. They're going to hang around for a long time and tend to soak into the plastic more than evaporate off into the atmosphere. On the outside of the pipe, it's easier for the solvents to evaporate away, and it's harder for them to soften too much from the outside. Can happen if it's really egregious, but it's less likely. It can affect the chemical resistance to things like mold inhibiting sprays on the outside of the pipe. Typically, when we have incompatible chemicals like that applied on the outside of the pipe, we'll see some cracking around the solvent cement beads, because we have kind of, remember the network I showed you of all the molecules tangled together. You're swelling that up, you're moving those molecules apart from each other, and it's the entanglement that gives it its strength. So when you swell those up, you've lost a little bit of strength, and you can actually get a little bit of cracking around the solvent cement beads, or drips of solvent cement when you have incompatible chemicals present.
Awesome. What are some ways, Michelle or Emily, that you can protect protect CPVC from incompatible materials? I know that we've seen, or I've seen in the field, people using the bags that the pipe comes in to create sort of a barrier or cardboard. Not that they're necessarily recommended, but that is, what I've seen. There's something called Deco Shield, for example, that is used um, more so on the for what stands for decoration than it is from compatibility. But what are some best practices you see there to sort of isolate the pipe?
For a lot of things, tubing insulation would be a good choice. For other things, it's a little more complicated. Like, for whatever reason, if you didn't want to use a compatible fire stop and wanted to use an incompatible one, there's not only the problem with the barrier, but there's the problem with those things are UL listed to be installed the way they're meant to be installed. So if you go sticking other things in the firewall, we can't guarantee that you haven't reduced its fire rating. So we don't deal with those kinds of questions at all. Just go use a compatible fire stop rather than try to work around an incompatible one. As I said, for things like molded hits, for wire, insulation may be a good choice, but for other types of chemicals, insulation may be more of a trap. So you've got to kind of use your brain, think about what you're trying to protect it from. But as long as you put some barrier there so that it's not touching. I've seen other people use, a size up of pipe to protect from things. You can just put another sleeve of CPVC over the top. Lots of different choices you could make, but you've got to kind of use your brain as to what you're trying to protect from and what's it actually going to do. If it's going to soak up the chemicals or trap them, it's probably not a good idea.
What about when it comes to freeze protection of CPVC pipe? One thing I want to mention is that there used to be, what was it, glycerin-based antifreezes on the market were leaking out of sprinkler heads and had an adverse effect on CPVC. But now that the market has transitioned to listed antifreeze product, the UL listing process actually includes compatibility testing with all brands of CPVC. So if you're using a listed antifreeze product, whether that be our product, BlazeMaster, Tyco's LFP, or Noble's Firefighter Eliminator 1330, those are all compatible with CPVC, ours as well as our competitor CPVC. But are there other, any sort of insulation and things like that you can use as well? I don't know if you had anything to add to that, Michelle.
Well, on the topic of freeze protection, I mean, it is important to use a brand name product listed for CPVC because, there's a lot of other types of antifreeze products out on the market, like propylene glycol based antifreezes would be incompatible and obviously wouldn't meet the fire standards either. And then there are even more aggressive types of antifreeze products like polypropylene glycol antifreeze would be even more incompatible. But these are not, in the NFPA codes, and they're not listed as compatible for fire sprinkler systems by UL either.
There's a question earlier that we got that I think maybe expanding upon would be good is mixing CPVC brands and manufacturer. We don't recommend it because of warranty issues or potential warranty issues, and because typically you want one manufacturer across the whole system. That said, any UL listed CPVC product is listed for use with another UL listed product, right? So the listing for specific applications, such as basements, for example, or other types of very specific listings, might be different. But from a compatibility standpoint and from a general listing standpoint, they are okay from that point. to use together. And, from a compatibility standpoint, there shouldn't be any concerns.
I I see a question about single component polyurethane foam. Yes, that is compatible for use with CPVC. And if you need some documentation on that, that's on the other topics, other compatibility topics page under gap filling.
Yeah, a couple questions on here about determining compatibility. What are some of the tests conducted to determine compatibility? And then to become part of our program, how long does that typically take?
The test is a strength test in contact with the chemical, or a long-term strength test. So it takes 6 weeks to finish the test. In contact with the chemical or some concentrated version of the chemical, there's a lot of different sample preparation methods that go into the various categories. You can't obviously test a fire stop the same way you would test an antifreeze. An antifreeze is liquid and a fire stop is a rubber chunk, sealant anyway. So in some cases we will, and as I said, like caulks and fire stops can take 10 years before you see the failure in some cases. And so we have to accelerate that in some way. We do that with various sample preparation methods, but the test itself is then going to be just a long-term strength test in contact with the chemical or some accelerated version of the chemical.
So one thing we didn't talk a whole lot about is failure analysis. And we have a good question on here on how can you differentiate an incompatible chemical failure of CPVC versus another method of failure? What do you typically look for? And is there anything that you can see in the naked eye versus, under a microscope?
You can generally tell by the naked eye looking at the fracture surfaces. Fracture surfaces will actually, they look more brittle than brittle actually looks. They look very glassy when it's a chemical resistance type of failure, because the chemical is, instead of ripping the molecules apart from each other, the chemical is kind of acting like olive oil on spaghetti. It's hard to pull the spaghetti strands apart until you put olive oil on it, and then they pull right out. The incompatible chemicals work on the plastic like that, so you get smooth, glassy fracture surfaces, as opposed to a smoother, duller fracture surface if you just have an impact type failure. Also, typically chemicals will cause multiple fracture initiation points, as opposed to something like an impact, which will cause just a single nondescript initiation.
What is the process for if someone has a failure or thinks it's been come in contact with incompatible material? What do we recommend the contractor does?
We recommend the contractor gets in contact with the manufacturer of the part. So if it's a BlazeMaster part, that will be IPEX or Viking, or if it's a legacy part that's been out there a while, JCI still has a complaints department you can contact. And they will either handle it themselves if they are capable and want to do so, or in a lot of cases, it comes back to us for examination.
Yep, and typically we're able to tell you, or Michelle's able to tell you, what type of chemical was introduced and how it caused the failure, or that it was not caused by a compatibility issue. Can you talk a little bit about how CPVC ages? And does it naturally break down over time? Is the interior smoothness of the pipe affected?
So CPVC does experience physical aging over time. So when the manufacturers make the pipe and fittings, they're made at very high temperatures and then quenched as they come out of the injection molder or the extruder. And so they're kind of frozen in an expanded state, and they are trying to contract over time, and that will cause some loss in impact strength. But CPVC does not typically break down into smaller pieces like other types of plastic do. Polyethylene, polypropylene, those types of materials will break down in smaller pieces, either due to oxidation or free radical from UV or something like that. That doesn't happen to CPVC. It's more of just a physical aging process. And the interior surface quality doesn't degrade at all over time. You don't get any roughening of the surface. I mean, unless you have, you know, actual physical buildup of just residue and debris from dirty water inside the system, the CPVC surface is going to stay just as smooth and shiny as it was when it was made.
There's a couple questions in here about UV light and its effect on CPVC, or where that myth came from. In the installation manuals, it says don't store it outside. And I'll give my 2 cents on that, and then, Michelle or Emily, feel free to step in. But as we said, it does not affect the performance of CPVC. However, it does affect it affects the color, but then also it can become embrittled, right? And that poses more risk from an installation standpoint. So you have to use different tools, and just treat the pipe with more care when you're installing it. So it's not so much that the UV is and the color change and it being embrittled affects how it actually works. It just makes the installation process harder. So no, we definitely don't recommend installing it outside, because we want to set installers up for success, and make it as easy as possible on them. So I think that, especially when we first came out with this product, we very much harped on that, and almost to the point where we scared people. Just say, like, best practice is don't leave it outside, and only install it if it's not discolored. We've really tried to soften a lot of that messaging just around that, over at least since I've started over the past 6 years, because I think it was actually detrimental. There's a distributor in Texas who left some, like, loads or bags and bags of CPVC pipe outside and ended up throwing it all away when they really didn't need to. They just needed to work with a good contractor that has, like, a good quality assurance program and knows how to handle, embrittled pipe. And that was sort of the point, was like, maybe we've gone a little bit too far in this, when they're throwing out thousands of dollars worth of perfectly good pipe that's just a little, embrittled. So I think that's the honest answer. Michelle, you've been around for far longer than I have. I'm not sure if you have any further insight into that.
No, I agree with everything you said, and I think you pretty much echoed what I said during the presentation. But this might be an opportunity too to add another bullet point to the other compatibility topics page as well. I was looking while you were talking, and it's not on there. It's certainly something we could put on there.
Agreed. And that all of that is on blazemaster.com. It's not on the FBC website, but anything about anything about UV light, as well as FPUF, and a lot of the commonly asked questions are right on our website. We actually just redesigned our website to make it more user friendly and answer a lot of the hard hitting questions that we get, make it easier to find. So I do recommend looking at that as well. Another question that I love, because I love the answer to it, is, does microbiologically induced corrosion, or MIC, have any detrimental effect on BlazeMaster? Oh, he asked about treatments for MIC. Darn it, I thought it was just MIC. But let's answer, does MIC have any effect on BlazeMaster? And then second, does treatment for MIC have any effect on BlazeMaster?
Well, MIC has no effect on BlazeMaster. I think we would have to evaluate what particular kind of MIC treatment you were using. Some of those will contain things like surfactants, perhaps, surfactants allow good wetting of whatever it is you're trying to get in contact with. And so a lot of bacteria killing chemicals, mold killing chemicals, and I suspect MIC treatments might also have surfactants in them. So we would want to evaluate it before commenting on those sorts of things.
Agreed. What about a messy installation? So spilling, using too much solvent cement, leaving solvent fingerprints. How does any of that affect the pipe?
So as I discussed a little bit earlier, on the outside, it's hard to have too much. I mean, big globs would be a problem, but fingerprints, small runs, certainly not. On the inside of the pipe, you really want to follow best practices for installation, and especially if you've got multiple fittings in a small space. You know, if you got a lot of little elbows close together where you're trying to get around an obstruction or something, you want to put plenty of solvent cement on the pipe, but as little as you can to coat the fitting surface, socket surface, because when you push the pipe into the fitting, the pipe pushes the cement from the socket inside, but the socket pushes the cement on the pipe outside, and outside is better. So light coat on the fitting and heavy coat on the pipe to make a good joint, especially if you've got a lot of them in the same area, because it can literally, I've seen it where you have cement from multiple joints just run down and find the lowest spot and form a puddle and just blow through under pressure after a few months.
We have one question that says, my understanding is that manufacturers have the right to exclude their product from the incompatible list if it fails testing. What percentage of products that fail to be compatible are included in the incompatible list?
The incompatible list is really completely separate from the compatible list. To get on the compatible list, we are very, very conservative. We have very high standards. We allow very little effect on the plastic. And so it's possible that things that are not going to cause field failures may still fail our testing because it is so conservative. And so failing the test to get on the program does not put you on the incompatible list. The incompatible list consists of products that either we know have caused failures in the field because we get complaints, that we've had to analyze, or in some cases, for instance, in a fire stopping caulk, there are certain ingredients, plasticizers like the ones Emily named. If I look at an SDS for a sealant that I'm not familiar with, and I see those same ingredients, then I know that that's incompatible. And so that kind of thing goes on the incompatible list as well. But simply failing our very, very conservative test does not necessarily mean that the thing is actually incompatible. Again, going back to what I said before, how hot is too hot? Some things may be pretty warm, but they're not too hot. So we don't necessarily exclude things just because they can't pass our very conservative test.
All right. Do another question. Does PVC glue or cleaner spilled on the outside of the CPVC affect it negatively?
It's certainly a matter of amount. Small amounts that, a smear that evaporates pretty quickly, that's not a problem. But if for whatever reason, maybe you had something installed, along a ceiling so that you spill it on there and there's a huge puddle around it and it can't evaporate very well, that's more of a problem. It's all a matter of quantity.
Right. There's a few questions about listings and things like that for ordinary hazard. Because this is a compatibility webinar, we won't get into those right now. Any of the listing restrictions or ordinary hazard room allowances don't have anything to do with chemical compatibility. It's mostly from a fire testing and performance standpoint. We actually just had another webinar a couple months ago on, so look that up on YouTube or on BlazeMaster.com if you want further questions about that. I will say that we can be used in ordinary hazard rooms of otherwise light hazard occupancies in rooms less than 2,000 square feet in 13R and 800 square feet in 13. So that is also a common misconception that you have to switch over to steel in some of those rooms, but really we can be installed, exposed, or concealed in those rooms under those sizes. Just reference NFPA and it will give you that language specifically. So again, I hope you guys found this valuable. I hope we got all of the questions. And if we didn't, feel free to reach out to us, but I think we covered everything in the chat that was relevant to chemical compatibility. We really appreciate your time. And as we head into the holiday season, I hope that everyone has a safe and lovely holiday. Michelle and Emily, I very much thank you for your time. And I hope everyone has a great holiday and a great rest of your day as well.